Today's lesson we are going to take a look at quadratic functions, and specifically we're going to find the vertex and the axis of symmetry. An axis of symmetry is just a line that divides an object, any object, into two reflective parts. So since we're dealing with quadratic functions, then our graphs are parabolas, and if we have a line of symmetry or an axis of symmetry, we are going to have it right in the middle. So this red one here, or if I move it to the other parabola, it would be located right there. And we would like the equation of these, okay? So first of all, it is going to be a vertical line because we're talking about quadratic functions, and functions have to pass the vertical line test to begin with, which means our parabolas will always open up or always open down. They'll never open side to side. So we're not going to have to deal with anything like that. And since our parabolas always open up and down, our axis of symmetry line is always going to be a vertical line. And what do we know about vertical lines? Well, we know that their equation is always x equals a number. And in this case, it would be the number 0, because that's where my line would cross the x-axis. In this case, at the origin, and in the other case, at the origin, and both of those would be the number x equals 0. But what if we had a parabola that wasn't centered around that axis, and it was over here instead? Well, in that case, you would need to find the number or the location on the x-axis that our line of symmetry or axis of symmetry passes through. So in this case, we can see it is 1, 2, 3, 4, 5. 5. X equals 5. Okay? Because we can see that the vertex point, the bottom point of our parabola in this case, is the point 5, 2. Okay? So it's pretty easy. If you have a graphed parabola and you know where the vertex point is at, right? Because your number in your line equation is exactly the same number as the x coordinate, okay? But what if it's not like that, okay? What if all we have is the equation? Well, we have two options. Actually, there's three options, but one of them we don't have to worry about because we're not covering completing the square. That's one of the options. Another option here that we're going to look at is using a formula, and it's over here on the side, over here in red. It is the formula for negative b divided by 2a. And remember, a, b, and c are just the numbers in our equation when our equation is in standard form. Okay? When it's in standard form. So this should look familiar because it comes from the quadratic formula, right? There's the whole quadratic formula that we just learned, and the first part is actually going to give us the axis of symmetry. There's a really good reason for that. If you're curious, I can show you later. Just give me an email. But let's just go ahead and try to plug into our formula for the axis of symmetry. X equals, and then it says negative b, so in this case that's going to be 16, and then we're going to divide by 2 times a. In this case, a is 2. All right, so doing the arithmetic, that's going to be 16 divided by 4, which is 4. So my axis of symmetry equation is just x equals 4. Now remember that 4 represents the first number in our vertex point. And if I'm trying to find the actual vertex point, all I need is the y-coordinate. And to find that, all we have to do is plug in our 4 into our function, right? So we know that when f is 4, I will have a line that passes through the vertex. So let's go ahead and calculate the corresponding y value. All right, so plugged it in, found f of 4, and we do the arithmetic here. 2 squared is 16, and 2 times 16 is 32. And then we have 16 times 4, which is 64, and then plus 5. So this is going to be negative 27, I believe. And that gives me a vertex point of 4, negative 27. Okay? All right, if you don't like that option, right, if you don't like to use a formula, if you can't remember a formula, there is another way to do it, and it is using the graphing calculator, right? We have to be masters of our graphing calculator. We already know how to find a minimum and maximum point of a curve. We've done that already in the last week. So we can do the same thing using our graphing calculator. So let me go ahead and load this one up, and I'll show you how to do that. I think we already know how to find a vertex point, right? And if you can use the vertex point on your calculator, then you should be able to just use the same thing. All right, so let's go ahead and do y equals. We'll grab 2/3 here, our fraction, 2/3, and x squared minus 3x, and then we have plus 11, and go ahead and take a look at the graph. Okay, so here is our lowest point on the curve. Remember, we go to second trace. We're going to choose option 3 in this case since we have a minimum, and we'll have to give it a left boundary and a right boundary. So click 3 there. So how about, where's my, yeah, let's say 0 is to the left, and probably safe to say 5 is to the right. 5 is to the right, and then maybe we'll guess 2 right there. Okay, so it's actually 2.25 and 7.625. All right, so we have our vertex point. I'm gonna go ahead and write it down. The vertex is 2.25 comma 6 point, what did we say it was? Come on, 6 point, no, not 6 point, 7.625. 7.625. So that's our vertex for the parabola, which means, right, we know this is going to be the number in our axis of symmetry equation. And it is an equation, so make sure you write x equals and then that number for your axis of symmetry. Okay? All right.